Good morning, still 20 minutes left in the morning, so hi everybody. Welcome to Copenhagen Developer Festival. Hope everybody will have a blast at the next 3 days. In the next 60 minutes, I'm going to talk you through using OpenSSF Scorecard to review NuGet Packages more easily for security. So let's get started. First, it's always polite to introduce yourself, right? So my name is Niels Stanis, and I work as a security researcher for Vercode. I've started out my development career in the early 2000s with the first bits of .NET, and I always kept an eye on security and software development in general. And then in 2015, I moved to Vercode, where I do a combination of that for our static analysis, right? So I'm programming a lot, which I still enjoy, which is cool parts of like dealing with new technology and how it works. And then we do that with static analysis, and I also do a lot of Rust lately, which is, I think is a pretty cool language. And I'm a Microsoft MVP developer technologies because of all the public speaking and community work I do. That's what I enjoy. I would love to share, and I would love everybody to build more secure software. And that's exactly what we need to get covered in the next 50-ish minutes. If you look at a modern application architecture, you can probably illustrate it like this. This is a slide I've used in all my presentations over the last couple of years because the problem space we're in with development, we build a lot of stuff on top of stuff that's built by others, right? Other bricks, and this is the XK CD that explicitly talks about the digital infrastructure, right? But you can just replace it. And then at the bottom, there's that small brick that's been thanklessly maintained since 2003 by some random person in Nebraska, right? Can you imagine if you put your company to risk to that small brick that's underneath, right? If it falls down or if it turns out to be bad, the whole thing collapses. And yes, we would love to use software that's made by others because I'm lazy as well. Reuse, that's the best thing, but you also want to make sure it's secure. You want to do the right assessments on the packages that you pull in, and that's exactly what we're going to cover in this session. First, I want to focus a bit on software in general and what are the risks that we're facing with the NuGet ecosystem. I'm not saying it's only NuGet, but the examples I'm going to give is NuGet. Then we're going to look into the project, Scorecard project of OpenSSF, which is part of the Linux Foundation. They have a cool project that has some metrics that we're going to use. Then we're going to look into some of the results and see, hey, how does it correlate to industry standards and what do we get out of it, right? How much value is in it? I can show you some metrics around how it works. And at the end, we'll have a conclusion and Q&A at the end. So an average code base, there are different studies, but let's say an average code base, 20% is code that you write yourself, 80% is written by others. And you can also question, like if I pull in a library and I only use a small chunk of that library, it's not necessarily meaning that I have it all. But technically we could say a small portion we write ourselves, a big thing is something that we rely on from others. And what could possibly go wrong? This is a report, and this is, I'm not going to talk about Vercode a lot, but I'm going to use this report because it has some good statistics in it. So the state of software security is something that we publish each year. And in our 2011 edition, we published something that almost 80% of the time, third-party libraries get never updated with the project, right? So people start out developing stuff, they put it in production, and then the thing is never touched again, which is a bad thing because, of course, we can have stuff happening over time, right? Vulnerabilities are found, things are disclosed, and we need to be aware of that. And how bad is it? I think everybody is probably aware of Log4j and what happened with Log4Shell, like almost 2.5 years ago right now, right? I think it was October 2022. 2 years later after it, Chris Eng, who's our chief research officer, looked into some data and said, like, did we learn from what we saw, right? So Log4Shell was technically a way of mingling with log files, and if you would have a payload included, then it might result in code being executed on a server. And Log4j is literally run in a lot of apps, right? So it popped up in a lot of different places. Some of them might have been fake, but I have seen payloads working on machines. And so what we have done, we have taken the metrics that we have and looked into, hey, did we improve? So we saw that almost 40,000 apps that we scanned used Log4j, and close to 3% were still vulnerable to the first CVE that was published. And if you know the whole story, you know that there was a sequence of, it was fixed. No, it was not fixed. Yes, it was fixed. There was a couple of series of fixes that they did. So there's also still close to 4% who only updated the first time and didn't do anything for the second and third patch that came after it. And the thing that worries me the most, which almost a bit of a laugh, but 32% rely on a version that's end of life that gets no support at all, right? You can probably see what the kind of risk that faces, right? You don't want that. If we look at an average code base, if we run stuff in .NET, you can see your application as a transitive tree of dependencies, right? The top is the one you write yourself, and then you add stuff to it. A package, another package, you get stuff you need for ASP.NET Core running, maybe some telemetry stuff you add but you will have a tree. But every package that's part of your application or every DLL that gets loaded will have the same access rights as the initial process, right? So you start out a .NET process, the CLR gets booted, and you will have access to every system resource you see over there. And there are ways to lock it down. That's a different story, sandboxing. I've talked about it in the past, but that's how it works, right? So if a module becomes malicious, these are, by the way, code cartoons created by Lynn Clark. She does a lot of stuff for Bytecode Alliance and WebAssembly, but these are just nice illustrations where she talks about security issues. So what if a module becomes malicious and wears a mask and decides to do weird stuff, right? Stuff happens. And if we look at NuGet ecosystem, yes, these things happen, and you can question the amount of stuff that gets targeted. In this case, they talk about a package that tries to steal cryptocurrency wallets from systems, right? Maybe a small group that's vulnerable to this, but it was probably worth doing because people did it, right? And that's of course the thing with hacking. If there's money to be made, then people will jump on it. So that's the thing that we see. Malicious packages included in ecosystem, and it's not only NuGet, it's on literally everything, right? Another thing that happened is, I think recently, this was published in July by a company called Reversing Labs. They do a lot of good research in the NuGet ecosystem. They showed that there's even highly sophisticated like weaving happening with DLLs, which they mingle in malicious code into existing libraries, which of course is really an edge case, but stuff happens, right? And that's something you need to be aware of. Like, how do you know for sure if you grab a package from NuGet, that's the package that you also look into if you look into the source files that are on GitLab or GitHub for that matter, right? You have no guarantee that that is the source file that was used to build the package. I'm going to talk about it in a bit as well, right? So if there's money to be made and people can do bad stuff, they will focus on ecosystems and try to get the foot into the door and say, like, hey, I can steal stuff from you. What else can happen? What else is part of what we do as a community if we develop packages? People are involved. What happened with people? People might be like convinced or maybe socially engineered to do stuff. So this is research done, I think it was University of Minnesota, and they joined one of the modules of the Linux kernel as a contributor, and that was their research. And then at some point in time, they contributed to the project, and they became malicious, between quotes. They showed like, hey, if I gain trust of people, I can grab a lot of foothold into a lot of systems, right? Can you imagine if you do this on the Ubuntu image and you have the ability to plant something in the Ubuntu image that I'm using in my builds, everybody uses in production, right? That's the whole supply chain problem you see over here. And it's a bit naive to think that this doesn't happen, right? People were not like, I think they were banned from contributing, which is like, okay, yeah, I see that they've proven their point, but banned is a bit of a hard thing. But does this happen in the real world? Yes, it does. Right? So this is something, the timeline, I think this was beginning of the year, right? Where they found out that there was a backdoor put into an SSH library. And that was done, I think a time window, the whole story, you can find it on the internet, but I think it was a time window of 3 years where somebody had a campaign where they tried to put stuff into the library. They downgraded all the security checks in order to be off the radar. They built in the backdoor, which had certain conditions to be run. And have you read on how this was found? I think this is still an amazing story. So one of the developers who works on Postgres for Azure ran his tests on the code base and saw the timing was a bit off. And she's like, this is not right. This is taking too much time compared to what I did before. And then he looked into the binaries and figured out that this was in, right? So that was the coincidence that we stumbled across this, right? And not to fear, like, or maybe say there's more stuff, but I cannot imagine that this is the only thing. Right? If people want to gain access, if you get a library that's used by a lot of systems and you plant something in it, you can do it. We need to do a better job. We need to understand what's inside. We're going to touch that in a bit. What else happens, right? Aside of being malicious, vulnerabilities are found over time, which can be triggered by an external rogue person with a mask again, right? What you see over here, like, hey, could you execute this on my behalf? So this is one screenshot I took this morning. I think this was 2 weeks ago. There was a denial of service with .NET 8. HTTP says certain requests will result into a lot of resources being eaten, your website becoming unavailable. That's a risk, right? So it's key that we update the libraries that we use to the latest versions if something as that occur. Luckily, we can do that with the .NET CLI. You get it for free, right? You can also use a commercial vendor, but you can also get it for free if you do development on your CLI. You can say, hey, list all the packages, and afterwards ask, hey, do you have any variable versions in this list? The only thing you need to be aware of is that you need to look into transitive tree of dependencies, right? This is the top level list you see over here. You need to explicitly instruct the thing to show you all the transitive ones, and then you see somewhere downstream there is a vulnerability linked to a version of Newton soft.json that's used, right? These tools are there, you should use it. I think this whole transitive behavior possibly will become the default with .NET 9 SDK, which I think is cool because this is the point where you can easily fix it. If you're developing, you know, like, hey, make sure that we're on the latest version, right? That makes sense. These tools are there, and you should use it. Just to make sure I'm referring to the slides, I'm referring to articles, all links and slides are in the slides notes, and I will have those linked at the end in my GitHub repo that also has the demo. So don't worry about keeping track of stuff that I'm talking about. The slides are already there on GitHub. The other thing is that we have vulnerabilities. Do we really know what's inside? And this is another piece of reversing labs again. I love the stuff that they're doing with NuGet. They looked into some packages and they saw that .NET, of course, is managed code, right? And you can do interop with unmanaged code. And they saw certain libraries that were using, let's say, for example, gzip, which is a compression library built out of source, which is like a linked DLL that was put inside the package. So it's not a package that refers to another NuGet system package. No, it's hardly linked inside of it. And that's the baggage that they talk about. How do you know that that's inside? You can't see it. You don't know that that's that's related to this code. The other thing that worries is that gzip is not in any way distributed as a binary. You need to build it from code. And the code version that was used in the stuff that they saw was one that was released in 2005 and had a dozen vulnerabilities. So it doesn't surface, you don't see it because it's been tucked in, right? Sometimes you cannot step out of that and you need to do some interop, but it would be good to have some sense of what's inside, and it would be even better if it's a hard relation with it into another package, right? So how can we have a better understanding of what's inside? What's a good analogy for us to use to get better understanding? That's a nutrition label, and I would love to see a nutrition label for software. So people are aware, like hackerspaces usually have Club Mate, which is like highly caffeinated drink. If you want to stay awake, you drink one of those bottles and you can stay awake. It's just 2 cups of coffee. It's normal, you could just grab that as well. But those have labels on it, and you see like the whole white square that has nutrition facts. The left-hand side is the US version, which are a bit off because in the Netherlands you will have like 100 mils and 100 grams will have this amount of stuff in it. And they use with serving size, which is an abstraction that makes it hard. On the right-hand side, you see a picture that I took in July in Berlin, where I was visiting a hackerspace. And you see, but it describes exactly what's inside, right? And I would love us to have similar things for packages. Just look into, like, hey, can I just give me an overview of what's inside? And that's exactly what OpenSSF Scorecards gives us, right? And the tool has the goal on doing that automated, which is nice, and it will run on top of a GitHub, Git-based GitLab system. You can run it, you can point it out, I will show you in a bit. And it will do some checks, and it will do a whole variety of checks, right? But there's a whole series of stuff that it does, and this is just going through the website, and then it will calculate a figure, and it will get a figure, right? Almost like sitting in class, and I've done my exam, I'm getting an A or a B or a 10 or a 1 in the Netherlands, how it works, right? But in this case, it's varying from 0 to 10. And 10 will be a good figure, and 0 will be a bad figure, right? And there are different areas of checks that it's going to look into, and we're going to go through them one by one in order to make sure that you understand what they're doing. But it relates to code vulnerabilities, right? So are there any open source vulnerabilities known? The maintenance done, how does it work with contributors? How active are the contributors? How many commits are being made, right? Those are all valuable metrics. Is there any continuous testing done? Aside from CI, CD, like unit tests, hopefully integration tests, but also security tests. They should be part of the stuff that you're doing. And then if we deal with source, you need to have access to source. How well is it secured? What about build pipelines and that kind of thing, right? Those are all risks that are also part of that with the build risk assessment, right? That whole thing makes up the system that you build. And that will give you some sense of how good a project runs their security. I think that's the key. So let's move into some of the checks. I'm going to go through bit by bit. So does it have open vulnerabilities? So OSV Dev is a website you can go to right now. It has a registry of all known vulnerabilities. In this case, this is a list that I published this morning, and you see the same CVE I just talked about also in this list. But the scorecard tool itself will use this one, and it will check if there's any known. And then based on that, it will have a score. It will also introduce a risk weight. In this case, this is a high risk problem. So that will have its effect on the calculation. You can find the calculation itself inside of the checks document of OpenSSF Scorecard. I'm not going to do like all the math here, but this one counts as high. We will have some criticals, we will have some lows as well. You will see that in a bit. Does it do any dependency update tool, right? Does it use dependabot or renovate-bot or whatever? The only thing I dislike about this check is it will just check its presence, that it's executed. But it doesn't mean that people do updates and stuff, right? But yeah, it's a start. Maybe we can do the checks as well if it produces, let's say, pull requests or something else to fix the things. That will be nice if they can correlate it back. Does the project have a security policy? If I'm doing research on a project and I run into a security problem that I want to talk about, it would be nice if I know exactly how to reach out to the team, right? Send an email, or hey, if you drop a message here, or even if you go to Microsoft, you find like, hey, if you disclose the stuff throughout this email address, keep in count everything, you might even be eligible for a bug bounty if they do it, right? That's cool. But security is normally, let's say, if you go to Git repo, there's a security.markdown file that will explain to you what they do, and it gives you information on what to do if you find stuff or stuff needs to be disclosed. Same counts for license. License is, of course, it's not a real risk, but if a project has no license, then you could question, should I use it in my production system, right? Maybe some licenses you cannot use if you're running your own commercial product that you sell. There's a liability, legal thing happening, necessarily not security, but something to be aware of, right? So it will also check to that. The other thing, if you look at maintenance, is that they have a CII, so continuous integration best practices list. So this is a project that was adopted by OpenSSF. And this is a self-attestation that every project can do. You can fill out a form and say, hey, I'm project maintainer for this. This is the Git repo, and these are the checks that we do. And then somebody, a person from OpenSSF, will sign off for it, right? So this is high-value checks. Fortunately, like it's a low thing, but it will show people like, hey, we have best practices for our CI/CD, because also part of the supply chain. Does it do any security testing? Does it do any test runs? Right? If pull requests are merged for that reason, right? That's a quality check. Would be good to have a sense of if it's happening or not. And it does it based on certain loss commits and then figures out a figure at the end. If you talk about security testing, fuzzing is definitely a valuable thing to do. It will check if presence of certain projects, and I think there's even more sophisticated things happening as well, more projects. You could question yourself, how much value do I get out of fuzzing .NET projects, right? Fuzzing usually is used in browser context, let's say in the old days, where if you have a plugin that has a memory problem, then you could do code execution in a browser. That's a valuable thing, right? If you want to sell it or do bad stuff with it, that's a thing. With .NET, managed, less of an issue, but you will still have logical things you want to work into, like as that denial of service we saw before with .NET. So fuzzing, well, it makes sense. I'm going to touch this in the improvement section as well, because I think there is. And the same counts with static analysis. So it right now checks if one of the CodeKello Sonar Cloud is used, but that's it. If the tool is used, and not necessarily what the outcome of it is. There's definitely room for improvement because one vendor is missing. I see that, but it will check the presence, right? This is of course a good practice. Static analysis is helping you out understanding what type of security issues you might have in your code base. Another risk assessment from source perspective is like, are there any binaries inside the source repo that are used with the application or with the package that is released? Because that's the baggage that I talked about, right? You cannot deterministically say like where is that DLL created with source code, because you cannot reproduce it. That's a biggest problem with that, for that matter. They cannot be reviewed. So this is a high risk. If there's always that test case that needs that executable, you can do that exclusion, I believe, but this is definitely a high risk. And the same counts for if you look at source. How did you configure your GitHub branches and how are they protected? And is it possible to like override a public branch by a forced push? That's not what you want. There are a couple of good best practices, and in combination with the dangerous workflows, there is a real good document at GitHub you can find if you work on GitHub Actions that will explain to you exactly what you need to look into, right? You don't want any untrusted code to be executed upon build or like used into the input. One good example is something that happened with VS Code. I think it was 2 or 3 years ago. Some researcher figured out if you file an issue, then nightly those issues will be processed, and one of the parameters was used in the build script to do a binary creation or a build step. And he was able to do code execution and then include another file in the binary that was created. I believe nicely disclosed, probably made money out of it, right? But workflows and stuff that gets built, that's a supply chain thing, right? We need to be aware of it. It will have influence on our outputs, and we need to be aware of it. So this is definitely a good project to look into if you're working on GitHub, right? I'm assuming GitLab probably has some real good documentation on this as well, to make sure that you don't do any default bad things, right? You don't want to do local admin or SA on your SQL server, because that's a bad choice. That's the analogy. Also, code reviews. Is there an implicit review done? So if somebody pushes changes and then has a pull merge request put in, somebody else needs to review it, right? The second pair of eyes. That makes sense, right? And it will check. It will check the last 30 commits and see if it's a different person that does this. And there's also, of course, a fact of contributors. And this is something I was a bit like in limbo about, like, hey, how do you need to interpret this? Because it will check if there's multiple organizations involved with the project, which makes sense, right? If there are 3 or 4 big companies and they are involved with a library that's used by a lot of people, then that's probably a good thing, because they all want to have it still running and in a good shape, right? That's the difference. Relying on a single person, that's the Nebraska thing you saw before. That's a risk, right? You don't want that. But it's a large list of contributors, a good thing. That's the thing I questioned when I created this slide first. Because if you look at, this is an NPM graph you can create. You don't need to see all the details. But if you see this dependency tree that starts out on the left-hand side, this is Electron. So if you use VS Code or Slack, you use Electron. And this is the dependency tree you get with that if you run Electron in your VS Code, for example. And I think there's like, how many? There's like 110 contributors, right? Or like close to 100 that are like touching this code. And those are the maintainers. There's almost 1,100 people who contribute to all these modules, right? There's a lot of people touching that code that end up in Electron on your machine, right? So you could question, is this a good thing or a bad thing? I'm going to show you some metrics that, I'm not going to spoil it, but we will get to this in a bit. I was a bit worried, like a large list, I'm not saying it's good. One is definitely bad, but a large list is good. We will see it in a bit. The other thing you need to be aware of is what will help is pinned dependencies. And that means that, of course, you need to update your packages, but you also don't want to. You want to make sure that everybody runs in the same version, right? And don't have any updates done without it being vetted properly before it's done, right? So you can do that with the restore packages with log file in MS Build, that kind of configuration. And what about the workflow actions you use on GitHub? You can point out to a version, but technically, I think you always see it in the IDE as well. You want to point out to a hash version, because then you are certain that that's the action that gets executed. A version can just be replaced with something else, and you're not aware of it, right? So if that version gets compromised, you want to know it. So that's better than to point out to a hashed version of that action in order to execute. That's the thing, we're getting close to the end. So the other thing is token permissions, right? The build actions that are run that need to have access to stuff. Once it builds, you want to have minimal rights. You don't want to have the SA administrator directly from the app to the database in the old days, right? This is the same with the workflows. If you have, it's just least privilege. It just needs to do what it needs to do, nothing more, right? because somebody might compromise that token and will have access to anything. And then the other key thing as well is packaging. You want the project to be part of an ecosystem. And if you publish to NuGet, you're part of the NuGet ecosystem. You can publish new versions. You can say this one is vulnerable. That will be part of the .NET CLI vulnerable thing you saw before, right? It helps out being part of an ecosystem because people can update. That's the key, right? And not have something stuffed in and you don't know about it. And then the last check is the signed releases. It will check if the project or the output is signed. And of course, you can question like how much value is that, right? And the biggest example would be the stuff that happened with SolarWinds. SolarWinds has got one of their build servers compromised. Somebody had persistent access, which means like they could just do stuff with it each time it built. And they were able to put additional stuff into the binary. And then it was signed at the end. And it was signed with the right certificate. So a normal user would still see like, oh, this comes from SolarWinds, I can trust this. Technically, that should be the case, but they, of course, were compromised before. So a signed package is not any guarantee of what's inside, but at least will give you the guarantee that what's signed at that point in time, right? And you can do the same with, there's a thing called build provenance. If you're interested in supply chain security, you can have build stuff signed as well. Then you know for a given fact that at that point in time, Niels Stein has triggered that build that was producing that package that has that hash. And then that's signed off. So that's a guarantee, a timeline that you can correlate to. I think that's the key. So it's important. Signing releases has value in that whole story, in understanding what's happening, right? Enough talking. These are like a lot of checks. The first time I got it, these is a lot of checks, but yeah. Let's look into OpenSSF and let's look into the tool and let's see what type of results we get back. So now I'm going to switch. I need to make sure I get out of presenter mode for you to see it. And yes, it is. I have done this a couple of times. I was like, hey, I'm not seeing anything. Yes, I need to escape presenter mode. So you can install scorecards. If you go to the website, I have it open here as well, I guess. Hold on a second. You can just go to the website itself. You will find how to install it. And in my case, I installed it on my Mac. And you can run it, right? And you can just say scorecard. And you can do it also based on a GitHub repo. In this case, I pointed out to a GitHub repo, right? So it might be a GitHub or a GitLab repo for that matter. And then you can say execute. And it will start doing all the checks. And this, I have connectivity, right? This is always the demo guide. So I have connectivity, it's running. It might take a while, but it will show us output, right? And in this case, it does it for React, Facebook. You also saw that you can do the same question for, let's say, I have this NuGet package, newtonsoft.json. Give me the scorecard of that. We're going to do that in a bit. I'm not going to bother you with it, but we will see a file that I produced based on that. So the output you see over here is going to be pretty verbose. There's a lot of information. I might need to collapse this one if it's completing. I'm not going to do a dance. That's not cool. But it's running right now. Once it's done, it will give us a table, and it will give us all the checks that were done, all the stuff that I just mentioned, right? So binaries, are there any binaries in the repo, that kind of thing. And once it's done, it will give the output. You can also, luckily, do that with JSON output, right? So that's something you could probably automate. So let me keep this one running, and let me show you the other part. So you can also get it based on JSON, right? So if you do that for a newtonsoft.json, you will see, in this case, it will have a score of 2.9 out of 10, which you could argue, is it good enough? And then if you go down, you will see all the different checks that are done, right? So there are no binaries found, so that's a score 10. Branch protection is not enabled, so that's a 0. So this will all add up, right, with the whole same weight. So we found 9 out of 30 approved change sets. We normalized to 3, so that's not such a good score. So we can scroll down. We have this, right, for this package. That's the thing. But if you need to run, as you've seen before, this tool is, I think it's still running. I'm not sure if my internet is flaking. Keep in mind that if you run this, you also need to put in a GitHub token to access GitHub with public read access. That's what I've done underneath already when I started out. Sometimes I need to drop the token in the console, but right now it's already there. It will take some time. Is this workable if you do this? And then I have 20 dependencies, but all the transitive stuff, that's not going to work. Luckily, all of the data is also available on the internet, like with the security scorecards itself. So if we go to, if you're able to see this, you can go to /viewer, and then you can say, this is the GitHub repo I'm interested in. In this case, it's newtonsoft.json. And there we see that this has a score of 3, right? So 2.9 is the one I run this morning. Projects have dynamics, right, over time as well. So 2.9 or 3 is almost the same. But you will have the same output over here. You see, hey, no binary artifacts found. That's cool. There's no publicly known vulnerabilities right now. That's cool as well. This is the score thing. But this is only working on a GitHub repo. And if I do a NuGet package, you need to translate that this NuGet package is belonging to that GitHub repo or that GitLab repo, for that matter. Luckily, there's another data set that's published by Google, which is called debs.dev. That's this one. And the cool thing about this is that you can just say, hey, newtonsoft.json. You can grab it. You can grab some additional stuff that they publish, but they also have the scorecard information over here. And in this case, they run it a week ago, on the 19th, on a certain version of scorecard, and it has a 3.2 out of 10, right? And then you will also have the different explanations on the checks that were found and that we see over here. So now you need to go to your project, copy, paste all packages of the solutions you have, and then grab this project, and then grab the scorecards in order to have that metrics. It's not working, right? That's not going to be a happy thing to do. So what I decided to do is I have a tool, a tool chain I call Fennec. And I created a thing that's able to understand .NET projects, and it will fetch all the scorecards for a project. So let me go to a project called DasBlog, which is, if you're familiar with, in the early days of .NET, we had blogging engine.NET. That was DasBlog. That was one of the first demo apps you saw. Somebody ported it to .NET Core, and this is the version. And if you go to GitHub, or if you go to NuGet, and you can just do a .NET install of the tool. I have a pre-release version that I put up this morning you can use. I will show at the end how you can get it. But you can say, give me scorecard like this. So this is a project. Let me just move up one directly into source. You will see there is a solution file in this matter. That's a solution DasBlog has contained all the several projects. If I now say, give me all scorecards, it will run, it will do the thing, and it will create a directory that's called Fennec, which will have a lot of JSON files. And let me open up this one in my code, and I will show you what's in it, right? So you will see that there are different projects that were identified. So in this case, it relies to AutoMapper. Let me format the document so we can see the score up front. In this case, must be somewhere, it's at the bottom, I guess, at the last bits. Yeah, in this case, AutoMapper has a score of 6.1, right? And these are all the files that you get for this project. Some of them might be empty because there's not really a project to identify, but this will at least give you a set to start out with, right? To have a baseline of things to go through. Is this a workable solution? At least it's automating everything you want to do. That's fine. But then how you easily do a review on all of this? I'm going to get to that in a bit. That's hopefully, I'm working on it, let's put it like that. So let me move back to my slides. Let's see where we're at with the time. Okay, cool. So Fennec, I will show you how you can install it and use it yourself on your projects. We've seen all the checks. I've thrown some metrics at you, like how good is it, right? Can we do some comparison measurements in order to industry standards to see like, hey, how good is it? So OpenSSF itself always, I think each year they publish a report where they talk about the work that they've done and how many, in this case, how many automated assessments were done on 1 million open source projects, right? This is cool. But isn't there another report of data that we can use, right? And this is where Vericode's data of software security comes in again, right? And the cool thing is that I was looking into this, and then Chris Eng, our Chief Resource Officer, did a talk at RSA about exactly correlating this data. So like, oh, yes, I can use this. So he has a whole presentation of an hour. If you're interested in, you should watch it. It's in the links. But what we have done is we've taken the analysis data that we have, and we compared it to OpenSSF Scorecard. And we've identified that if you see the blue bubble here, just hang with me for a second. The blue bubble is the whole OpenSSF covered projects. The blue intersection is the one that we see with our customers, right? So those are the enterprise apps that we scan and that are doing dependency analysis on their projects. And we've seen like a smaller section of that. So we can definitely say something about like how good is that and how well does it perform. And what we have seen is that on average, if customers scan or if projects are observed by us or are part of the apps that we have seen, the scores are usually higher, right? So they probably take security seriously. You can also question some of the open source projects that were analyzed by OpenSSF might have got no value for businesses, but we definitely see a trend that if we have seen it in projects used by customers, we know that the score is higher, right? So that's a thing that proves that this will work. The other thing that they also did is they looked into some GitHub data and correlated back. I think this one is pretty cool. And bear with me because I'm going to explain to you a bit what's happening here. The font is a bit too small, so I need to maybe get new glasses or look a bit closer. But if you... I was talking about the contributors in the beginning. So the top left one chart over there, that will correlate the amount of contributors, right? So that's the Y scale, so that's 1 to 1,000. And then the scorecard score is 2 to 8. And then we see that the amount of unique contributors, if that's higher than the score of the scorecard, will also be higher. So that proves that a lot of contributors, unique contributors, right, are a good thing to your project because that will result into a better score. The same counts with committed diversity, which is like unique. You don't want to have one person doing all the commits. You want to have a team of people that commit to it, right? And if that's the case, that's a figure you can calculate. And if that's the case, there's a lot of people involved, then the score is also higher. Right? Makes sense, right? So I think this is cool. The top right one is related to the amount of days in between activities, right? So if a project is actively maintained, then the scores are higher. Makes sense, right? That confirms it as well. And then the last commit one, that's the active commit, and also the last commit one. If a project is stale, right, then the scores are probably low. That also makes sense. But these are some good metrics. So they've done some slice and dice, and it's some big data magic, which we had an analyst helping us out with. But it will definitely give us a sense of like how good it is. And then at the end, they showed this. And what this bar means is that if it's red and if it's high, then it means that a lot of security vulnerabilities are found in the library in this case. And what they've done is they've taken out different checks. You have a positive and a negated result of it, right? So if there's a license or not, right, that's a positive and negative result. And what we have seen is that if no update tool was detected, then the likelihood of a vulnerability being found is red, is the highest bar, right? That's high. If a project is being fuzzed, they also found a lot of security problems. Makes sense, right? Fuzzing expose security issues in your code base. I think that's pretty cool. And if there are no binary artifacts, then that will reduce the amount of security issues that were found, right? The same counts for signed releases and static analysis. So I think this is cool. And the other thing is also pretty odd is like the second one is security policy. If you have a document that explains to people like, hey, if you find something, you can reach out to us and talk to us. That also increased the amount of security problems that were found inside the security thing. I think that's cool, right? That will show that this works. So this is some metrics, and as I said, there's an hour talk if you want to see it, if you're interested into that. The report you can also read. What are the things that we can improve, right? So as I said before, within .NET, we have some things. And the first thing I questioned when I looked into this is like, how much value do we have with fuzzing? Because fuzzing normally would mean a lot of unstructured data against your app and see how it behaves. And if it's doing memory management as well, then you might have got the jackpot and you can execute stuff. So it's definitely good for that. But will it have any value for .NET? Yes. There's a project called SharpFuzz, which has been around for 5 years. As this blog post indicates, that was published a year ago, a little bit more over a year ago. And AFL is a fuzzing library, and SharpFuzz relies on that. And it also introduces support for libfuzzer. But there's a whole blog post where the creator talks about the stuff that he found. Different CVEs, bug bounties, all of it, right? So this is pretty cool. And I think the key thing we need to keep in mind is that we need to be aware of the context of the stuff that we're fuzzing. And one example I want to give you is this. So This is a piece of C# code that uses JSON serializer. This is one of the demo apps you find in SharpFuzz. And what the key around this is that, hey, we're interested in fuzzing how the JSON deserialization is done. So we want to maybe throw in some mingled stuff and do some coverage-based fuzzing. That's how they call it, right? So less hitting it with a hammer, more structured data into it in order to see how it behaves. And this is exactly creating like a skeleton app, right? It will take input, and in this case, the stream itself will be fuzzed with a JSON document. You will instruct SharpFuzz saying like, hey, this needs to be a JSON document, and it looks something like this. And that's pretty cool, right? And then, because this is a tech conference, what do I need to drop at least once? AI, right? If you have an LLM, you could maybe create test cases for the right context and throw it against this, right? LLMs are definitely good at doing that. They're also pretty horrible at other things, but if you have enough context and it talks about code, then the odds are high. And Fuzzomatic is a Rust project I run into, which does exactly that. I think this is cool. I would love to see similar things done for .NET, if I only find the time to do it, right? That's always the problem. The same counts with static analysis, right? As I said before, the text that they do is like, is this tool run? Is the tool run? Does it mean anything, right? You could question yourself. If you run this against a tool, then what's the problem in this case, aside from the fact that it probably uses a password and then creates a SHA-1 hash out of it, which you don't want, right? That's a real bad thing. The SHA-1 hash will probably be flagged because that's a call you don't want to make. Maybe you want to do it because you do a performance thing with, let's say, caching of stuff. Then it totally makes sense. Then collisions are less of a worry compared to passwords, right? But it all depends on static analysis. You can flag this. You can do a Roslyn analyzer, and it probably is already dead, that will flag this method and say like, hey, put a squiggly underneath and say, look into this method, because I'm not sure if you want to call this right here. Do you want to revisit? The static analysis I would love to see is more like the skeleton-based one you saw also with fuzzing, right? And I'm sure if you're able to read this, it should be big enough. But if you have an ASP.NET controller that exposes a method that will generate a customer report, and then it will have a customer data input that traverses and that will be propagated into the reporting component. And if it then opens a file, this is a file issue, right? I can control the path of the file that gets opened. Yes, Niels, there's a .pdf at the end, yeah, but I can truncate path and file names. You can do stuff with it, right, depending on the OS. There's definitely room of doing something with this, right? This is a static analysis I would love to see. The only thing you can get this running for if you have that skeleton, right? That add a test app that puts that component into a bench. So I would say I would love to see more of this type of static analysis checks in relation to .NET and scorecards to tell us like, hey, they're covering it in this way. That makes sense. The other thing I mentioned before is, key thing is we need to have reproducibility checks. How do I know that this version that's in this GitHub repo on that branch is used to build that package? I want to have some guarantee. Roslyn is pretty deterministic based on the inputs it gets given. You find there are design documents within Roslyn. You can see like what are the conditions. I think it has to do with some stuff that's installed, but it's pretty deterministic. But how reproducible is a simple console app? I have a demo, I'm not going to do it, but if you have time going to the GitHub repo, there's a demo script that you can do with a console app, and you can see how it behaves. If you create one app, copy it, and then build it, the same app twice, who would think that those binaries are exactly the same? Because that's what you want, right? That's reproducibility. You will see that there's some bits and pieces off. The IL, the .NET IL, MSIL that's inside, will be exactly the same, but some other things will be different. You want to be able to reproduce. So Fennec right now has got one argument. I'm not sure if I pushed it out on this version. I don't think so. It's in my development branch. But I want to be able to say, hey, this NuGet package, check its reproducibility. NuGet can refer to a source repo and to a branch that was used to be built. And then if we automate the checks and say, hey, just grab the source, try to build the package and look into the .NET DLLs, we can have a comparison. So like, hey, this DLL is the same, or somebody stuck additional stuff into it, right? We have that check. We should automate that. That's the .NET reproducibility. I would love to see that. And Fennec diff is there, but it's work in progress. Creating tools and releasing stuff yourself and being scrutinized for security, for my own security, is always a thing. But I'm working on it. As I said, the preview is there. You can use at least the scorecard stuff. The other thing I would love to see is more related to know what's inside. And in 2019, I believe it was 2019, Microsoft released a application called Application Inspector. And this runs on source, but it will give you a sense, and it will look into source files and see what type of libraries are used, right? And it will see, hey, do you do any data storage, or do you do any like more reaching out? Do you use any OS integrations, that kind of thing? And if you then zoom in on the report that you can create, you can see, hey, I'm mostly confident that this one uses cryptography, and you maybe want to review it. But if this is a library that does math, why does it need to do cryptography, right? That's the question, like have a sense of what you expect of a library. Object deserialization, I don't expect that to be in a library that only does simple math, right? Why? Why is that there? That might be a risk. But this will give you some insights on the thing, and I would love us to do this on IL. So the first version of Fennec, I had an API dumper in it, which will just dump all calls that are done inside of the library. And I use that in order to focus on the things that I would find interesting if I do a security review, because there's always time and that kind of thing, right? You want to focus on the highest risks. I would love to have similar reports that you can just say, hey, this NuGet package, what does it do and why? And that's a nice metric to see. And then if we look into what else can we do? And as I said, I'm doing a lot of Rust, and Rust Cargo is the NuGet for Rust. It's about crates, and it's about stuff you pull in. So what they do is they have a project called Cargo Vet, where people of the community review packages and sign off for it. And with Cargo Vet, it's a CLI tool as well. You can say, hey, check my packages against this database. And then you will see that a person from Mozilla has reviewed it, and it says like, hey, I didn't find anything obvious, or might be an issue, or look into this. This is quite cool. This community-driven security reviews, right? Security researchers already disclose and fix stuff with people, like if there's any bug bounties involved. But I think this will be a cool thing if we can get this with the .NET ecosystem as well. Being able to share stuff, right? That's totally cool. So I'm going to wrap up a bit and jump into the conclusion, and then we definitely have time for questions. So looking at all of this, right, I think Scorecards is definitely a step forward as the project that we can use to have better understanding of what's inside and how our stuff is built and maintained, also related to supply chains, right? You want to know what the risks are, and Scorecard should never be a goal on its own. Yeah, I'm OWASP top 10 compliant. That's the biggest BS, of course, to say, but this is the same, right? You should use it. And looking at all the checks you saw, you can also focus on the stuff that matters for you, right? That figure is just the total figure, but maybe you want to know for sure that every project gets fuzzied or has static analysis, right? Those are metrics that are just in all those reports. You can find it, and you can do more stuff with it. Cool thing is that that NuGet also is working on a .NET score that they want to expose more metrics on a NuGet package. And there's a design document if you go to NuGet Designs, and I think it's also in the links, where you'll see like, hey, we want to have more metrics. If you're doing a lot with Node, NPM, Node.js, look into socket.dev. They've got pretty cool stuff as well. They will have the whole expandable security graphs, also transitive and all risks. I think that's cool, and NuGet definitely looks into those kinds of projects to get more data flowing out. I would love to have my CLI improve, as I said, with the diff, with getting the insights. I'm working on it. And what about a trust graph, right? You saw all the separate files. Wouldn't it be nice if you have one report saying, like, this is the project I'm looking into, give me a nice, big, shiny report, but that allows you to navigate, say like, hey, this is the top level package, this is the transitive one. Yes, I've got it on my list, like a type of dashboard. A tool always needs a dashboard. That's what I heard somebody else say to me. So that will definitely be a trust graph thing to add. And I would love to contribute back, right, with additional checks to Scorecard. If you want to install the tool right now, you can do the .NET tool install. The -G is global. If you want it on a single project, remove that. And if you do Fennec -- pre-release, you will get the version I published this morning. It will still do the API dumping, and it will do the scorecards based on what it finds. And underneath the hood, it uses the projects and it will traverse the project it finds, right? I want to add stuff because .NET is not the only ecosystem. I have some proofs like using NPM or Maven files as well, POM files, if you're doing that right. I think it's naive to say that one technology is used in development. We have a lot of maybe front-end, back-ends that are different, right? So it would make sense to add that as well. So with that said, I'm going to open up for questions. This is I gave this talk at a conference that had a Star Wars theme, so I created some nice pictures of it, right? So this is C-3PO asking questions. The first GitHub repo, that's the repo that contains the demos, the files, the scripts you saw before. If you want to email me, that's my email, and I'm also on Mastodon, and the one on the bottom is my website and my blog. I will definitely post once I have my pre-release out and say, this is V1. V1, I'm getting close. I'm just being too hard on myself. But at least right now you can use the pre-release and look into the files. And then we can move on from that. So with that said, I want to open up for questions. Thank you for your attention. If there are any questions, I'm not sure if there's a mic or not. Otherwise, I will repeat the question to make sure everybody gets it. Yeah.
You showed a slide where you say that if it's there is a security property, then usually it means that the package is not secure. But you also on the same slide there was mentioned that if you have this zone cloud of control, then probably it's less secure, right?
I'm not saying it's less secure. I'm saying more stuff is found.
Okay.
And hopefully fixed, which makes it more secure, right? And the markdown file, I think. The fact that the policy is published makes sense that people, they thought about the process, right? So I think they're pretty mature. They're taking the next step on publishing a policy, and that makes them hopefully better than somebody else who has like a big, like just black box, you throw something in it, you don't get anything back, right? I've disclosed stuff with people and they don't respond. Even if I try to explain like this is a serious problem if it gets exposed, right? And that's a hard thing. And then that policy will allow people to go directly to the right person. So it makes the project more secure. And the graph that I showed at the end, it shows that if they use it, more stuff is found. But that's a good thing, because if it's found, it's publicly found, and there's a fix for it. Right? So it's more related to the amount of security issues found. It's not saying that security is good or bad. It's more like the outcome of it. And that's good, right? I think I should worry about if a project is stale and everybody uses it and nothing gets disclosed in the last 3 years, I should worry about it, right? That can be a risk. And that's also if you see the whole contributors mark on Scorecard, right? It will tell you like, hey, this project hasn't been touched for a while, so it scores a 0 in that, right? That's a risk. And then you can at least pick the stuff that you find interesting and then work your way down in order to do a risk assessment. That's always the thing. Like I always get the question like, Niels, how can I have a guarantee that my app is secure? Yeah, it depends on the risks that you're facing and how much money and time you can spend on it to fix it, right? And you want to do the best and reduce the risks that matter to you. Thank you. Thank you for your question. Yeah. Yes, please. When you use the scorecard, so keep in mind that I'm reviewing a lot, so I'm not necessarily. If you would write a production software, you create a new project, then you could probably do it. If you do product security within your organization, so it's more related like on when would you use this kind of thing, right? If you have a mature organization that does product security, there might be people who are responsible for vetting all libraries that everybody uses within the organization, right? There might be a base list of stuff. I would suggest that team will be the best to do this kind of assessments on these scorecards, right? If you're like a two-people team, then at the beginning you can run this. Versions change over time, vulnerabilities are found, so it would make sense to do this frequently, maybe every release, in order to have a view on what's there. And then you need to do something sensible with the data. As I said, those set of files, it will give you the metrics, but now it's time to do the next step. It would be cool if you have a nice dashboard to see like, hey, it evolved, or this become worse, or this is good, or this is bad. That's the thing, right? I'm still in the middle, like, hey, which direction I wanted to take. So I think that will be the best moment, right? So if you start out doing something new in a smaller team, you can do it yourself. And if it's a bigger organization with product security, they probably have. You need to use this version of AutoMapper in order to be compliant with the whole company, right? Everybody needs to be on the same in order to do it. Does that make sense?
Yeah, sure.
Okay, thank you.
Have you done elaborate based on the score?
I'm sorry?
Have you ever taken elaborate out of your project based on score?
As I said, I'm mostly focused on reviewing. So production systems, I think it has been a while since I wrote a real like production system side of this tool. So I'm not like doing business to business. I mostly write test cases that we use to do our static coverage, right? So I would look into a score and say, hey, this is high or low. And I would mostly focus on what's inside because I want to know how it works, right? That's my goal. So I have different interests. If I would run this in production systems, I would probably do it more often. So this is something I started out at the beginning of this year, right? And yeah, it's evolving. Thank you. Yes? I'm sorry.
So what is high and what is low? Is there a threshold?
It depends. As I said, you should look into the checks that matter most. It's a starting point, right? Don't. I would be, yeah, good one. Good one. Depends. I cannot answer that on a closed fashion, saying like this is the stuff that matters most. The low-hanging fruit, the high ones. If you look at the risks, the GitHub risks you have, right? Those are pretty obvious ones. The binary artifacts, I think the high ones I would mark off first, looking at that, and then work your way down from that, and to increase the score. And if you look into a project and see, as I said, it hasn't got any contributors over the last couple of years, that's a risk, right? And that's how you can use it. So it's, as I said, it's not a goal, it's data you can utilize. How you can use it, I had the same problem, like if you look at supply chains, you can produce a lot of data. And what's next with that data, right? You need to take well-informed decisions. So, and that's the struggle. I think this is the first step, and then let's see how we can use the data in a good way. That's my goal. But let's exchange details if you have more questions, and maybe we can look into stuff that matters to you and say, hey, I would focus on this or that. Yeah? Thank you. Yes?
I'm one of those people who make intro projects and put binaries in the sorry about that. But what should I do? How should I go about that? Because
Sometimes it's a necessity, I guess, right? Makes sense. Then people can still, you know that it's there. It's done with a reason. Let's say if you're then able to still correlate that binary back to a source repo, that will be the guarantee I would love to see, and then still be able to reproduce that as well. Reproduciblebuilds.org is also a real good site that helps out with different other tool chains to explain, hey, how can we check for reproducibility with a managed code, with Java, with all the other systems. So I would say correlate back to where it's built from. That should be the only thing. And that's probably not reflected in the score, because then you can say like, hey, there's still a binary, yeah. And then you can maybe make the exception. There are exceptions you can put in as well, explaining what happened. Cool, okay. Then I'm going to wrap up. We're going to be around. If you want to talk more about your questions, you just ask, come forward. Let's take it offline. One question from the organizers, because I think the intro video didn't take place. You make sure you vote at the end of the session. Put in a green one if you like it. Put in a yellow one if you say like, oh, Niels, or a red one if it's really bad. If you put in a red one, please come forward and talk to me. No, that's fine. But make sure you vote in all the other sessions. It's important for the organizers to know what the content is and it meets your expectations. So enjoy it and hopefully see you around. Thank you.